Okay, so we are going to talk about how to change uh, between z-scores and raw scores, which actually allow us to compare things a little bit more substantially here. So our objectives for this lesson will be to convert between raw scores and z-scores, and also we're going to find the area under the standard normal curve, which actually corresponds with the probability. So let's present a situation here. So Tina and Jack are in different sections of the same class. Each section is large, and the scores on the midterm for each section follow a normal distribution. That means they follow that bell curve. In Tina's section, the average was a 64 and her score was a 74. In Jack's section, the average was a 72 and his score was an 82. Who did better related to their class? Well, if you're going to go straight up on percentages, you would obviously say, okay, well, Jack did better because he scored higher. But his section, his class average was much higher than Tina's. They both scored 10% or 10 points higher than the average. So how do you tell? Well, if we knew how spread out the data was, we'd be able to figure this out a little bit easier. So the missing topic here happens to be the standard deviation. But what if I were to present you with a graph instead? So here's kind of the distribution. So Jack's section has a much higher standard deviation. But Tina's section has a much lower standard deviation. That means the scores were closer to that average versus Jack's, which were more spread out. So if we plot each of these points according to their graphs, we can look here and see Tina's section, while she only scored a 74, is actually to the much higher end than Jack's, who's still kind of here in the bulk of the curve. So related to their class, Tina obviously did better. So we need to be able to convert between the two. So if I were giving you a score on a test, just like Jack and Tina there, if we convert it to a z-score, it will tell us where on that curve those scores fall, and then we can compare them, when normally we wouldn't be able to do that. So this formula is hugely important. We've got to remember these formulas. And z-scores, like I said, you're going to, x is our raw score minus the mean, and then take that whole thing divided by the standard deviation. But sometimes if you're given the standard score or z-score, sometimes known by the same thing, we need to convert it back to know what the original scores were, and here's the conversion of that, which really is just this equation up here solved for x. So these formulas, big deal, important. So let's do an example with this. A pizza parlor franchise specifies that the average or the mean amount of cheese in a large pizza should be 8 ounces with a standard deviation of only half an ounce. An inspector picks out a large pizza at random in one of the pizza parlors and finds that it is made with 6.9 ounces of cheese. Assume that the amount of cheese on a pizza follows a normal distribution. If the amount of cheese is below the mean by more than 3 standard deviations, the parlor will be in danger of losing its franchise. That means the z-score can't be more than -3. So standard deviations tells us, or the z-score tells us how many standard deviations away from the mean it is. So how many standard deviation from the mean is 6.9? And is the parlor in danger of losing its franchise? Well, following our z-score formula that we had, we're going to do our x-score, which is 6.9. Here, let me change this to a font that we can actually see a little bit easier. So our x-score minus our average score, it should be 8. And then we're going to take that whole thing, whatever we get for that, and we're going to divide it by this standard deviation, which in this case is only half an ounce. So if you were to do that, so 6.9 minus 8, and then take that answer divided by 0.5, you get an answer of -2.2. So while that is clear down on the end, it is not this 3 standard deviations. So let me pull in a picture here real fast. Graph. Oh, here it is. So -2.2 would fall right down in here. So if we mark it, it'll be right there. So nope, not 3 standard deviations. We are still within our range. So no, they're not in danger of losing their franchise.